Hello, I'm Victor. So today we'll be looking into machine learning. So before we proceed, you see, everywhere there is this buzz about machine learning. There's a hype kind of about machine learning. Virtually every industry talks about the application of machine learning to various fields. I mean, whatever they've done, they want to apply machine learning. So what exactly is machine learning and why do we care? Right. At the heart of machine learning is your data. So data is what is actually fueling this hype around machine learning. The proliferation of internet and then the availability of data from sensors, from your mobile devices, from so many. Data is almost everywhere. It's like an indispensable tool now used both by academicians and even in the industry. So just like Andrew Ng said that data is the new oil, right? You see, there are lots of data and we don't know what to do with it. That's where machine learning comes into play. But before we dive into machine learning, we should understand that machine learning has a relationship to artificial intelligence. So machines were considered as intelligent if they are able to do tasks that mimics human behavior. So that's why if you look at this diagram, at a broader scale, we have artificial intelligence, which is what? Basically making machines mimic the behavior of human beings, right? So inside artificial intelligence, we have machine learning. So if a computer is able to do a task without being programmed, it's said to have applied machine learning. We said to have applied machine learning to such tasks. And again, inside machine learning, we have our what? Deep learning. So if you view it on a larger scale, you see that deep learning is a subset of machine learning, which is a subset of what? Artificial intelligence. What does that mean? Can we make this simpler? Yes. So let's visualize artificial intelligence as a country. So the country is India. And machine learning as a state. So the state is Karnataka. And deep learning as a city. So that city is Mysore. So if I say I'm Canadian, all right? Okay, so you say you are Mysorean. Okay, you say you are Mysorean. That means you are Canadian, so you are Mysorean, right? You live in Mysore. That means you live in a state known as Karnataka, right? So you are Mysorean. Invariably, you are also Canadian. Obviously, you are Indian, right? So that means before we even look into machine learning, we should somehow know that machine learning does not exist independently, right? So artificial intelligence is the bigger umbrella, and inside that we have machine learning, and then the one which is modeled after the human brain is known as what? The deep learning. So here when we talk about deep learning, we are talking about number of hidden layers which has been added to the what? Your artificial neural network. So you remember, machine learning here revolves around so many subjects. We will look into that in a while. So that's why if you remember clearly, machine learning revolves around intelligence, right? That's what we said. So if it revolves around intelligence, what exactly is intelligence? Can we define intelligence? Or what constitutes intelligence, right? So if we say someone is intelligent, what does that mean? What does that mean? So let's take a while to understand this. I have a dog, okay? Hypothetical, okay, I have a dog. So my dog always observes me go take a newspaper from the vendor and keeps it in a particular place. And I also have a robot. The robot basically does nothing. It just sits there and it does nothing. So after some time I decided, why don't I automate this process? I'm a busy person. So let my dog go do the picking of paper and then fine, I'll be busy with other work. So I thought, okay, there might be times it won't be conducive for the dog to go pick the paper, the newspaper, and then bring it right there where I wanted it to be. So what I decided to do was I programmed the robot to do the same thing. It's an assistive robot. Now, I programmed the robot just to go to a particular location using the sensors and the camera, just pick the paper, and just bring it to another location. So it's kind of a garbage in, garbage out procedure. Go, picks that, and then comes back, and that's it. So next time, the vendor comes and throws the paper a little further apart from where it used to be. So my dog went, picked it, and brought it back. The next day, the vendor repeated the same thing. Now is the time for my robot to go pick the paper. My robot worked. On reaching there, it searched the sample space. He couldn't find anything. Then it came back. In this case now, do you consider the robot intelligent or the dog intelligent? Okay, you guessed it right. If you say the dog is more intelligent than the robot, you are right. If you say the robot also is intelligent, you're also right. Why do I say that? See, I programmed the robot giving a limited samples, right? So I've shown it that this is where the paper will always be positioned. So if the paper is not there, you got to just come back, right? So I should have given it a wider sample space, say, or wider possibilities. Say you look left, you look right, you move maybe 3 meters to the right and just check, or maybe move 3 meters to the left and just check, and explore all possible combinations. Then only you come back. So in this case now, both are considered intelligence. So can we say intelligence is ability to perceive your environment and act accordingly? Right. In that case, in robotics, yes, that is considered intelligent. And the dog also, ability to even learn from experience, right? Because it knows that at times the vendor might just throw it a little further apart. So that also is also intelligent. Now, what we always think is, people are considered intelligent if they perform better at a particular task. For example, there are prometric tests or there are standardized tests that checks your ability to perform in a written interview, right? So, people that get shortlisted for jobs, they will do so many rounds and then they will get to this thing to where they want to test your cognitive ability or they want to test your logic, right? So they will tell you to do this, and you see most people don't make it beyond that stage. So do you say they are not intelligent? I disagree. Because see, if someone is not vast or he doesn't have a domain knowledge, if someone lacks a domain knowledge, that doesn't mean that the person is not intelligent. So in the same way, if a program lacks a domain knowledge, that program is said to be unintelligent in that particular sphere, okay? So only when you have considered all possible combinations, you'll be able to say that this program is really an intelligent program. So, or this machine is really an intelligent machine. Now, what usually happens is, we look at the less educated people and we say, oh, they are not intelligent. Do you know that there is something called native intelligence? Many of them has these problem-solving skills which beats my imagination. Some knows how to, even make crafts, which for most of us, we attend tutorials and won't be able to do that. Just that they are unable to communicate fluently in English doesn't mean that they are unintelligent. So intelligence is multifaceted. There are so many aspects of intelligence, which if you want us to list it, we might say understanding is a form of intelligence. Learning is a form of intelligence. Cognitive ability is a form of intelligence. Problem solving is a form of intelligence. So intelligence is an unexhaustible space, a search space. If you view it as a search space, there are n number of combinations in intelligence, in defining the term intelligence. So why does that matter? Because if you say the ability to apply knowledge to manipulate one's environment or think abstractly as measured by an objective function is intelligence. And that's the reference point which we are taking, is intelligence. So, what could be this objective function? What could be the environment? You've seen it in the previous examples. Okay? So that the robot, which has a limited sample space or I fed maybe limited data sets, was not able to perform. That doesn't mean it's not intelligent. If I increase the number of possibilities, in that case, it's considered intelligent. You see those that have native intelligence, if I define intelligence only by their parametric test in, say, in IQ tests, fine. IQ intelligence quotient, which measures how much someone knows as a ratio of how much you know in a particular subject. Okay, so if I say, okay, my IQ test is this much, does that mean I'm not an intelligent fellow? I have seen people with very low IQ, but they are brilliant entrepreneurs. Okay, so that is why it's so important to understand what we mean by intelligence. So with that, we look at definition of machine learning by various authors. Remember, our aim is We are still here on machine learning. So various authors have defined machine learning, and if you search the internet, you see machine learning is the ability for a computer to work without being explicitly programmed, or ability for a computer to exhibit intelligence without being explicitly programmed. That means you are not every time you are not writing codes that makes the computer to do a task. You allow the computer to learn, okay, from past experience. So that is why Tom Mitchell gave a clearer definition. He says, and I quote, that machine learning, a computer program, okay, in this case we can say a machine is considered intelligent, okay, or a computer program is said to learn from experience, E, with respect to some class of tasks, T, and performance measure, P, if its performance at that task as measured by P improves with experience. All right. So if we look at this way, what I just defined is there is a task. All right. So permit me to use this. So what Tom Mitchell is trying to tell you, we have a task designated as capital T. We have performance measure. Performance measure designated as with capital P. And then we have experience. That is E. Right. So we take classical examples to understand this in depth. Remember, for a program to be said to exhibit intelligence, it must have at least to learn. For a program to learn, it must have these factors in place. So let's take a more generic definition, which says that machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. So if you look at it this way, we want to construct computer programs that automatically improve with experience. So what do you think the task is there? What is the task? Writing computer programs? Obviously. So what do you think now the performance will be? So if I write this program, say a program that will classify whether a mail belongs to the junk or to my inbox. So generic name for it is whether a mail is spam or not spam. There are n number of possibilities. So I need to look at all possible words, okay, that makes a mail to appear as spam or non-spam. So you see, initially when I run that program, it might even give me some wrongly classified instances, right? So when I feed it in again, then it improves, right? So that time it has learned from what? The previous data, which is your past experience. So the best way to understand this is we always take the game of checkers as an example, right? So in checkers game, what we talk of is this. What is the task? What is the task in game of checkers? Playing checkers, that's the task. Right. So what do we mean by then? How do you measure the performance? How do you measure the performance? And what do you think the experience will be? So the performance will be the percentage of time. The percentage of time it plays game and it wins. I mean, the time it played the game and won against opponents, right? So percentage of time, game won, right? So say the first time it played against an opponent, and maybe it might be a 50-50 probability, right? So the chance of winning might just be 50%. Next time it has learned. What is the experience now? What is the experience? So it has practiced this game over and over again. Right. So it practices it by playing against itself. So we always say that the best way to improve is by comparing yourself with yourself. So am I at my optimum? Is this the best version of Victor? What can I do to make sure that I'm living my life to the fullest? So don't compare with another person. So in this case, this program, the checkers program, since it's an automated program, will just play this against itself, fine, and then try to see the number of possibilities. And with this, when it plays against an opponent, it will be able to apply all the strategies it has learned, playing it any number of times. So, why are we talking about checkers, which even I don't know how to play the game? How about Ludo? Many of you play that. I have even played that also, the Ludo King. So what do I do now? In Ludo, let's model Ludo as an intelligence program. Right. So, what is the task? Playing Ludo. Specifically playing Ludo King. What's the performance measure? So my performance measure P will be the number of times I've won against opponents. So what I do, I can play against the computer, obviously the program itself. I can play against some random opponents online, or I can play against a friend, right? So I will try these three possible combinations. So first thing, I might even play against myself if it is in the real Ludo, right? The first toss, I'm going to move. Second toss, again, I'll take a move. I will see in these two who will win. So if I'm playing against a friend, again, I'll take a first move. Then my friend will take the next move, and like that until the game ends. So you see, in such cases, I can play against myself. I can play against the computer. I can play against an opponent, right? Which is a random opponent, which I get online, and I can play against a friend also. So with experience, see, with practice comes experience, right? That's why you cannot teach someone to have experience, right? This plays a vital role even in the industry. They will ask you, how many years of experience do you have? I've seen people fake it. They say, I have 5 years of experience. Fine. So you place him at a managerial position, right? So you have to be the product manager. And he goes and messes up the whole thing. That's to tell you that you can't just by reading blogs or by watching YouTube videos gain experience. Experience comes by practice. And practice has to be consistent, okay? So, I hope that is well understood. Now, the next thing that bothers me a lot is, do machines learn? Do machines learn? See, we've defined machine learning, right? We define machine learning now. Can you recall? We defined machine learning. We said that a computer program is said to learn from experience with respect to some class of task T and performance measure P, if that performance at that task as measured by P improves with experience, right? So, can you answer this question? Do machines learn? All right. So if you say machines learn, I beg to disagree. Now let's look at it this way. Okay? The truth is, machines don't learn. Do you know why? What learning is all about is trying to find a mathematical formula, which if I apply it to collection of data, okay, which we call training data, gives me the desired output. I repeat again. Machines don't learn because what we call learning here is just a mathematical formula or mathematical model. And we get to that in a minute. See, if I want to fit a linear model, okay? So I want to fit a straight line on this. So I have some values of y, plotting it against some values of x, and I want to fit a line, and the points are here. How do I choose this line? So you will look at that later. We call it regression, right? Linear regression. So is that line the proper one? Can this line go through this? Can't it go through this? Right? So in trying to do this, the machine is learning. But wait. I said machines don't learn. That what they actually do is finding a mathematical formula, which when I apply it to collection of inputs, which we call training data, I have to supply the coordinates, right? The x and y coordinates. I have to supply it, right? Then the machine will produce the desired output. And that led to another question. Okay, if it doesn't learn, why is that not learning? See, if you just said that machine don't learn, right? But you are telling me again that if I model this properly, I'll be able to get my line of best fit, right? Fine. Such that this is my regression line. Fine. Linear regression. And you are telling me that the machine doesn't learn. Now, why is that not learning? If I feed in the wrong data, what happens? It gives me the wrong output. Remember, machine, generally we say a computer is an idiot machine, right? Whatever you feed into the computer is what it's going to give you, right, as output. So I now feed some random values in that. It will predict an output. You might think, okay, this is not a classical case. It's just the same thing I'm doing. Now let's look at this in medical diagnosis, okay? We have radiologists whom they were assigned to look at an X-ray of an individual and see whether there is an abnormality in that. Abnormality can be the presence of a lump. It can be maybe like, say, an inflation, and maybe like in some region. Just let him find if there is something that is abnormal with that data, okay? With the image, medical image in this case. So what the radiologist does is, he's so tired, he's like, okay, he just flips through some stuff and say normal, 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 abnormal, normal. So, and he contain about maybe like 100 X-rays from different patients. Now what happens next? If he says the person is normal and the person is suffering from emphysema, it's a classical problem, which is just an enlargement of the lungs, okay? So if the person suffers from emphysema and he says it's normal, do you know it can lead to death? And same thing you fed into your machine, your model. You fed it into your classifier, and it predicted that, obviously, this is labeled data. We'll get into that. It's a labeled data. So I'm going to give an output that is normal. So when it sees other samples also that are similar to that, it says the patient is normal. So where does the mistake come from now? The mistake came from the human experts, right? So in this case, machine doesn't learn. Is that clear? Now, if you say that is not learning, okay, why is that name machine learning attached to it? It should have been called machine intelligence. Okay, again, it's similar. It should have been called something, right? Something. Maybe your genetics, maybe just find some fancy name, right? So why did they keep that name machine learning? See, it's all about marketing strategy. When Arthur Samuel coined this word in 1959, okay, he was working with IBM, and he said, see, machine learning is a cool word, right? And everyone echoed it. So when they started marketing that, machine learning, they attracted lots of prospective what? Investors, and even what? Very good employees. So now you understand that that word, cool, right, was what attracted everyone, okay? So in the same way, if we say, now you know for sure, the same thing applies to artificial intelligence. As you can see, that artificial intelligence is not intelligence. So is machine learning not learning. Remember, there is this big problem that we face in the world of AI, with so many for AI and others against AI. So the race is towards developing what we call artificial general intelligence, right? So can a machine or can a robot be able to work exactly like a human being? Can I put it this way? Can we replicate a model that will be able to reason, do everything like a human being? It's still very difficult. Deep learning, machine learning, AI has given us lots of scopes in the industry. That's why you see flying cars even in the US, and you see even self-driving cars as well. But the future is still bleak because it has to observe from a human expert, right? And you even see instances where plane crashed because it was autopiloted. And even in some cases also, the car also crashed, despite having access to humongous amount of data. So that is why, if you look at it this way, intelligence is very complex for a computer to achieve. We might achieve that artificial general intelligence where a computer will outperform humans. See, I'm not saying computers are not outperforming humans at the present. I'm saying computers will multitask, right? So if you have a robot, it will do everything for you: wash, swab, clean, type, do everything. So we are still far from it, but we might even see it becoming a reality in the nearest decade. So if you see, we are here, right? And now you know that computer actually don't learn. So how does this machine learning now differ from the traditional programming? So what happens traditionally when you program? And this is very important. Let's take, for instance, I want you to write a program that will compute the sum of two numbers. So what do you do? Okay, you can choose, okay, fine, I want to write it in C, and you choose a compiler. So you write the program from the main, then declaration and whatever. Now after that, what do you do? Prompt the person to enter the first number, say 3. Enter the second number, say 5. Return the sum. That's it. So what is happening in traditional programming is, you write the program. You write the program. Here you write the program. Fine. And then you supply sets of data, which we call inputs to the system. So this data is known as input, right? So there is a program, and you supply data to it, and what the computer does, it compiles and gives you the output. So the output is generated, right? Traditionally, what happens is, you write the program, okay, and then you feed it to the computer, giving sets of inputs, and it generates the output. So what happens in machine learning? The same block diagram you see, but here the output becomes an input. Okay, please listen. So this output goes straight to this, right? So, and then the data will be there because you need to supply the data. In this case now, this data becomes your training data. Training data. And this is your output. You ask the computer, write the program for me. So here I need the program. So in simple terms, what I'm saying is, I have an output. I've given sets of images, say medical image. I want to predict whether that person is suffering from maybe any chronic disease or something. So I've given it those sets of images, right? And I put some samples also, which I call the training data. I feed it into the computer. I said, fine, what is the program? So the computer will be able to predict, okay, model it, and then give you the results. So that is how traditional programming differs from machine learning. And that led us to another thing, because we can't talk about machine learning without talking about various types of learning. Various types. What are the different types of learning? You remember that whenever we talk of machine learning, you must have heard of these keywords: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and so on, right? So I try to fit it into this small space. So look at machine learning at the center. Revolving around machine learning is unsupervised learning, supervised, and what? Reinforcement learning. So what do we mean by supervised learning? Supervised learning. So in supervised learning, you have to give the computer what we call labels. So labels will be provided. Wait a minute. What do you mean by labels now? Here, there are no labels. No labels. No label data. No labels. There are no labels. Okay. Here, labels will be provided, right, in supervised. Now, let's take example. When we are in UKG, okay, or UKGs, or standard, or lower standard, what the teacher will do is, the teacher will come and say, okay, fine, today we are going to learn about numbers. The teacher will start telling you 1, 2. Most times, they back it up with actions, right? So it registers in the child's brain. Oh, 1, 2, 3. After repeating maybe a number of times, they now tell, okay, you stand up, count from 1 to 5. The child will repeat the same thing: 1, 2, 3, 4. Maybe they get to the writing, where the teacher will now say, whenever you see an instance like this, 1. This is 1. Okay? That is 2. This is 3. Now, what constitutes 1? If this is 1, how about this? So tomorrow, the child will say, no, ma, my mom taught me that 1 must have a cap and like this. Right? The child is still correct. At that stage, what the child does is, whatever he sees you say, the child will repeat. So in this case now, labels are provided in form of images. It can be in form of pictures also. Another example is when the child, maybe let's say the teacher comes in and says, now today we are going to study about fruits. And the teacher now gives the child an apple and says, see, whenever you see something like this, it should look like an, no, not orange. He will not confuse the child. He says, looks like this, red in color, you know, smooth body. That is an apple. Right? So the teacher brings the apple and shows to the kids and says, see, this is an apple. Tomorrow, what happens? The teacher has not told them about an orange. Bring something that looks like that, maybe might be a green apple. Comes and shows the children, some might predict that it's an apple, or some will say, Mom, you said apples are red. Is this an apple? Mom said, yes, this is also another type of apple. That registers in their mind. Another day, Mom brings an orange and say, what is this? What will the kids do? Some will say, Mom, we don't know, Mom. Mom will say, okay, this exactly is an orange. That registers. So here, you can consider supervised learning as a small child learning from a mentor. So the relationship is like the child has to be tutored. So that is supervised. Labels are provided by the instructor or the teacher. Now, in unsupervised learning, there are no labels provided. So this can happen, say, in an instance where you have to prepare for an exam. All right? You have not written exam of such. Say you want to go abroad, so you need to write some competitive exams. The nearest training center might be in Bangalore, and you need to give the results maybe in 2 weeks. What do? You have to rely on the internet, or you have to rely on what? Yourself, right? So that is self-learning. So self-learning where you have to log on to the web, search for some information, get that, compound it together, and then try to, modify and then improve on that. Here, there are no labels. No one will tell you, okay, this is how you should study. You should study 5 hours a day. You should study 10 hours a day. No. You figured it out yourself, right? So, in this case, in unsupervised, there are no labels that are provided. But you will see there is a little deviation when we get to what? Dimensionality reduction and clustering. How about reinforcement learning? Okay. Reinforcement learning, we can't talk about this without talking about robots, right? But before we get into robots, think that you are lost in an island. There is no help anywhere. No food, no water. Okay, or you are lost at sea, because if I say an island, fine. There was a shipwreck, and you are the only survivor. Just think, okay? No communication systems, nothing. At least you have to survive, right? So some people survive by even eating leaves, maybe some fruits. They end up becoming wanderers. Many people tend to survive by even, you drink the salt water, it won't kill you, right? Which on a normal note, you wouldn't do that. So what has happened now? Your body gets activated and you enter into that mode of survivability, where you have to do all that is within your reach to survive, right? So what have you done? You perceive the environment. You acted on your previous experience. Maybe you must have read a documentary of how people survived, lost at the sea. There's a movie also, okay? So how they survived maybe for years, okay? Without even any human help. So you read about that and you said, see, I have to put up a final fight. You struggle, you do your best, and you made it until help comes your way. So this is what robots do. So you see a typical robot navigation problem. That is a path that is set, right? So if the robot moves and hits an obstacle, It must have been, it tries to avoid, see, if he has an obstacle, what it can do, tries to take an alternative path. So it uses what? Sensors, cameras, to perceive the environment, right? So once it perceives the environment, it tries to maybe at least go avoiding that obstacle. Even in game playing, we use reinforcement learning a lot. Because the aim of a game has to be won or lost, right? See, even if it's drawn, you have to break the tie, right? Either through extra time or through penalty kicks. I'm talking about football, okay? So you see, when we talk of reinforcement learning, it's an English word, right? So you have experience. You need to apply that experience to a new situation where you don't know how to come out of it. And obviously, maneuver that situation and emerge victoriously. So that is reinforcement learning. So what most of us do in machine learning, majority of the tasks revolves around what? Supervised and what? Unsupervised. Because if you have followed some competitions or you've attended some machine learning boot camps, you see the first task they usually give is to predict survival rate in that Titanic that sank, right? Or they'll tell you to classify whether a mail belongs to spam or not spam. Or they'll tell you to maybe like try to segment this or to do a kind of a customer segmentation project, right? It's very difficult for them to just, any of the trainer to jump directly to this, right? Asking you to program a robot or maybe asking you to develop a game. Fine. So in that case, when we talk of classification, here we are talking about what? Whether that is present or not. Remember, I want to classify individuals according to their gender, either male or female. Okay, third gender exists, no problem. Or I want to classify whether there is a presence or absence of a disease. So classification, if you look at it this way, is usually a yes or no, true or false, right or wrong answer. As simple as that. So I want to see example. I went to an ATM and I swiped my card. Listen carefully. I swiped my card and then withdrew the money. And then I just told them that someone swiped my card and they withdrew. So can they catch me? I mean, can they be able to say whether that is a fraudulent transaction or not? So they will have to rely on cameras, right? So what if there's no camera at that ATM which I went and withdrew? So they have to rely on what again? My shopping behavior. See, have I swiped this card randomly before? Can this, there are lots of things they have to look into and then investigate whether I was actually the one who swiped that card or not. Another thing is, like I gave you an instance before, a medical X-ray was labeled wrongly. If I take that and feed it into a computer, it will classify wrongly. It will classify right, for sure. But when I investigate that again, I know that what actually happened was a misclassification. So, classification, obviously, I'm asking an obvious question. And I expect a yes or no answer. How is it different from regression? Because I said here there are always levels. So regression, let's look at weather forecasting. I look around, I say, okay, will it rain tomorrow or not? That question is, I'm predicting a continuous value. I hope you're getting this. So I have to look at historical records of a particular location. So I want to understand the weather pattern of my soil. For me to understand that, I need to look at what? Historical records, usually from what? The meteorological department or whatever. And then I take that record, I try to understand what happened. Is this the season of monsoon? Is it summer season? With what type of season are we in? And then I model it accordingly. So that's why if you see people that do lots of online, Forex trading, right? They want to predict the price of dollars against, say, rupees, maybe next week. There are so many factors that they have to consider. They don't just say, okay, fine, oh, US is world best economy or something. No way. So they have to look at other factors, economic factors that contributes to what? Fixing the price of dollar. Okay, if I want to compare US dollar against Canadian dollar, there are so many things I have to look into. So here, there are lots of data that is available. You have to look into those data and try to infer a meaning, right? So when I'm inferring a meaning, here, especially when I'm doing this, I can now think of regression comes in different ways. So can I apply a simple linear regression? Can I apply a logistic regression? Is it a multivariate regression? You know, there are so many possibilities in this case. I hope you got this right. So regression, I'm predicting a continuous value. I'm predicting something that changes almost frequently, right? Whereas this, in classification, is just a yes or no answer, a right or wrong answer. And if I get into clustering, clustering is an unsupervised approach to machine learning. And I believe in your 6th semester, you must have studied clustering in depth. So what happens here? It's just like some segments. You know, I'm trying to group people based on what? Some similarity matrix, right? You must have studied about your Minkowski distance measure, your Euclidean measure, right? Fine. And then Manhattan also, all right? So what are we doing? For me to say that these people belong to a particular cluster, there must be something in common, right? So clustering aims to maximize the relationship amongst, okay, let's make this simple. There are 3 clusters, A, B, and C. There are 3 clusters, A, B, and C. I hope you can see this, right? So here, I have this, some shape. Fine. And there I have another shape. And here I have another shape. So there comes one shape. This one I have classified as cluster A, this cluster B, and this cluster C. And this shape comes in now. Which cluster would that belong to? So, in clustering, the distance from the center of a cluster to points on the other neighbors must be minimum. So, this distance is known as intra-class distance. So, the intra-class, meaning distance between the same class, from here to this class A, must be minimized. And inter-class, meaning, see, the distance from, just watch here, from this center to the center, so the center is known as centroid, right? So from this center to the center there must be maximized, right? So because this is minimum, we tend to group them in one sector, and we call it what? Cluster A. The distance from that to there is maximum. So then we go here now and we check. How about the distance from the center to the nearest neighbors here? So the distance from here to the nearest neighbors, they are very minimal, right? They are very small. So this one, it belongs to what? The group or sector, cluster B, and this is cluster C. Remember the question. This one comes. Which cluster will it belong to? You might say it's closest to cluster C. Yes, because of the way I drew it. But you have to compute. At least you can use your Euclidean distance measure, right? Find the coordinates of this. Find the coordinates of this point. Say the coordinates might be maybe 7 and 8. Then try to take the coordinates of the center of this, fine, and check which one is maximum. If it is farther apart from A, then it has to belong to B. Because obviously you can see, sorry, it has to belong to C, because obviously you can see B is farther apart. So, having understood the basic background behind that, clustering is used in what? Customer segmentation. So what do we mean by that? In the industry, I want to know whether these guys, this group of customers are my potential customers, so that I will target them, right? I push ads, you know, like targeted marketing. I'll just push some ads, some products which they are really interested in. As we know, youngsters, they love gadgets, right? So I can't keep the old pushing, maybe like giving notifications to old people about maybe new mobile phones, laptops, and all whatnot. No way. So you see, by default, people that tend to, purchase laptops and expensive phones are maybe young adults from maybe like age of maybe 20 to 30, just for instance. Okay, I'm taking that as a reference point. Okay, whereas those that tends to maybe take purchase items, maybe like domestic items, are people maybe like 40 and above. Okay, that's also just a kind of random example. So with that, I have been able to group them, right? So I segmented the customers. These are my potential customers. So I'll push some ads, some targeted ads to this customer, and the other customer that belongs to a different cluster, I'll give them a different ads, right? So, and this also led to what we call targeted marketing, because as a market manager, okay, or as a manager of a company, or even the CEO, you want to maximize your return on investment, right? As a CEO, you can't keep targeting everybody. Okay, I have a product which I know it will sell more in India, and I keep pushing the advertisements over there in Africa. Do you think Africans has to pay and then maybe for all the export and all whatnot? No way. They rather get it locally made, right? So there are times we have to import, no doubt about it. But what I'm talking about here is you should target the audience. Capture them. There is a niche. There's a particular group of people which you are targeting. You get them, and then you see you maximize your return on investment. So before I wind up, I want us to go through what we've done today. We started by looking at the introduction of what? MHLI, okay, machine learning, by taking a closer look at how it actually mirrors artificial intelligence, right? And again, deep learning. See, it sits at the center, all right? And then we looked into what constitutes intelligence, right? And then we look at definitions by various authors, with the proper example given by Tom Mitchell, which we defined machine learning based on these three criteria, right? Performance, task, and what? Experience. And then the obvious question, do machines learn? Right. And then how is traditional programming different from machine learning? That led us to what? The types of learning. In the next class, we will look into how machine learning is actually related to all different fields, right? And then we'll be able to understand how we design a learning system and address the challenges or the issues that begs attention in machine learning. Thank you so much.